Thank you, Rowan. This is about the mineral exploration CRC, but I'll just point out saying that we actually are not explorers. We are undertaking research in mineral exploration, not an exploration company per se. And we're looking at future technologies. And the reason why, first of all, in Australia is fairly clear when you look at a diagram like this. So on that map of Australia, we have all the deposits and mines coloured by commodity. They're all the dots. And you'll see up in Western Australia, the iron ore in the red, a lot of gold and nickel in Western Australia, the copper in South Australia, coal across to the northeast in Queensland. And underlying all those known deposits are areas of brighter colour on that map. And those are outcropping areas. And that's where geologists wandered around 100 years ago and kicked the rocks, and where the process started, it was a lot easier to explore. And that triggered drilling and it triggered discovery. The rest of that map is coloured grey. That's about 70% of Australia is coloured grey because there is no outcrop, everything's undercover. But we know, of course, the rocks and where the mines are continue under that barren cover. The geophysics tells us that. And we've been doing geophysical surveys for the last 50 years and still ongoing. But to crack that conundrum, to explore under the 70% of Australia that is relatively underexplored, and we know that from drilling, there's very few drill holes, and we can see clearly from the discoveries in the mines, there just haven't been discoveries in that areas. It's not that there's no mineralisation or economic, that there's no ore there. The fact is we just haven't been able to drill and explore and discover under that. So that's what mineral exploration CRC is about. It's about exploration in these areas in a cooperative manner. So the model we operate under, the federal government puts up funds for cooperative research, which can occur in many fields, in everything from space to Antarctica to food science, many fields of cooperative research, this being one of them. And there have been a few cooperative research centres, CRCs, in the resource industry, and ours kicking off in the middle of last year with funding over a 10-year period. So it's a significant initiative with participants from the mining industry, the exploration and junior sector, from research institutions, from the geological surveys, and from the METS companies we talked about earlier, the ones that can commercialise it. And so we cover that technology of exploration as well as ancillary aspects, including safety, environment, and training of aspects of that exploration industry. And basically, utilising that along with this program called the National Drilling Initiative, which are all the geological surveys from all the states and territories coming together to utilise some of those outputs in each state to generate further pre-competitive data and ultimately result in further drilling under those areas of cover and ultimately discovery under those areas of cover, with the bigger picture of stimulating both the mining industry as well as that supporting METS industry that commercialises ideas and takes them to the world. So it's a collaboration network between all those groups. And as I said, 36 partners and counting. We have numerous of the majors. We have supply companies, drilling companies, service companies, of course the state governments, South Australia, and all the other geological surveys, and research institutions, including CSIRO. We're headquartered in Perth with both UWA and Curtin. We have dual headquarters as well as here in Adelaide with Assay and Adelaide taking part, as well as we've got some input from ANU and Newcastle as well. So it's a broad input to tackle a problem. But the problem of research and the reason why there's federal funding is that it has to be an industry-identified problem. So we're solving problems that industry have put up there. They've come up and said, great that universities do work, but we want work that we're proposing. So they're industry-defined problems tackled by researchers and able to be commercialized by those METS and METS companies that are able to take those to market. And there's various reasons why companies join up, but particularly mining companies are after better, more efficient and cheaper exploration and costs. So that's the primary reason, and so they're not competing for technology, but they would like service companies to provide better technologies, hence that cooperation. So we arranged in 3 programs, and I'll give the snapshot now and then just go into those in a little more detail. So basically a program on drilling technologies, that's drilling per se. And this requires radical improvement. Tim, you'll be pleased to know it requires radical improvement. We've been drilling holes. Everyone knows in the 1890s there were 1,500-meter exploration holes drilled, except they took something like 9 months to drill a hole with a steam-driven drill. We have coiled tubing now that you can drill a 500-meter hole in 4 days. Now that's radical improvement. And so it is happening. It may be the same technique, but applied in different ways. And as well as safely and in different methods. But so there's a strong emphasis here on drilling, because we all know drilling has to continue. You have to get down and sample an ore body. So there's a program on drilling optimization and on coiled tubing itself, and you would have heard about the coiled tube rig. There's a series of projects under a program on the data itself, data being generated. And again, I'll touch on those in a moment, but including Assay, Petrophysics, primarily downhole geophysics, surface and downhole seismics, as well as the automated use of that data. And then those are run across into this National Drilling Initiative where the surveys are all participating, basically understanding all the data that they have already, getting the most value out of that data, and then understanding it in the cover sequence, because if you don't understand the cover, you can't explore underneath it. But then, of course, understanding the basement, because if you don't know what you're looking for in the basement, it's no good looking through the cover, as well as the mineral systems that may be in both the cover and the basement. So those are the sort of overview of those, underlain, of course, by what the mining companies want, what the METS companies can develop and commercialize. The surveys contributing with education, training, as well as place for further opportunities that certainly exist. And I'll just give you a short snapshot now that we're underway. This program 1, drilling optimization and automation, that is looking at RC drilling and diamond drilling, how we improve it. And it's a radical improvement. In the total 10-year time frame, the goal is to decrease costs on those current drilling techniques by 50%. Now, that's a pretty hairy, audacious goal. And, we've started where there's, for example, at Curtin University, there's a drilling lab. It's got a drill rig in the lab, and we're drilling under lab conditions, as well as instrumenting machines in the field to do some serious sampling on deposit drill outs of both RC and diamond rigs. Things like 20,000 hertz sampling on an RC rig to understand the mechanism better, bring it back to the field, bring it back to the lab, and then run a loop, and how you can improve that in the first 3 years of that program. And then the coiled tube rig, you would have seen pictures of it in the past. It came out of the Deep Exploration Technology CRC, the DET CRC, and that rig out of DET was capable effectively of 500 meters depth, and went on to drill trials here in South Australia, in Victoria, and it's been in Nevada for the last 6 months. Barrick have been drilling holes and doing very well out of that. And one example of coiled tubing, how that is going to radically improve things. Coiled tubing can drill and has drilled at the same speed as RC drilling, using about 10% of the fuel of an RC drill. So in fact, I should sign up for Oz's program if they want to do some reductions. 10% of the fuel to drill at the same rate. Why wouldn't we be looking at that in a serious way for that sort of drilling? But we're improving it. We're taking it down to 1,000 meters, making it steerable, and improving that sample integrity from depth drilling. And that's in the first 3-year phase. Each of these, I'm talking about a first 3-year phase of exploration, of research, when we reset those programs to run for 2 more 3-year phases. On the data side, Downhole Assay, this is in conjunction with CSIRO. This is fairly ambitious to basically get a sensor, in this case primarily a LIBS type sensor, and put it down a hole. Now, we know that these sort of sensors work on the surface, but it's a bit of a challenge to put it down a 1,000-meter hole underwater in a dark environment and get a similar sort of result. These are the type of challenges. So we're not building widgets because companies do that already. We're doing fundamental research, which may or may not be successful, but it's audacious that we can get to goals that haven't been attained yet. And then from the petrophysics side as well, subsurface sensing, oil and gas uses coiled tubing technology, but it's in soft rock. It's a very different beast, applying sensing and steering in hard rock at depth, which is part of the goal of this. And already the first designs of the sensors are being undertaken in the first half of this year, so the project is underway with our geophysicists. And then the seismic itself, the same. Sure, reduced drilling is an aim. If we can do it smarter, we'll be drilling 5 holes and not 100 holes. And one way to do it is to utilize seismic to better target and apply your drilling. So the early work started on our seismics. We've done some in-hole testing already of different receivers, as well as a virtual mine framework. So the seismic application to smarter exploration is now underway. And lastly, the data wrapped up in these first 2 data programs is the 3D automated modeling. Now, this is somewhat different in that it's not something that's directly commercializable. It's open source, it's going to be. But having said that, Micromine, for example, has signed up and they're part of the project because it's still a great development. It doesn't matter if it's open source or not. Companies are still interested in understanding what the mining companies want to do in the 3D modeling space and what the surveys want to do with sparse data to basically have what we call plausibility filters and be able to filter data and model it in a rapid way. And then on the right-hand side, the National Drilling Initiative. As I said, the 4 big surveys, South Australia, New South Wales, WA, and Geoscience Australia, all putting in substantial funds to utilize the output and the drilling techniques from Program 1 and Program 2, both the drilling and the data processing, utilizing it in their areas to drill a whole lot of holes to generate pre-competitive data. That then, of course, stimulates exploration, it stimulates discovery, and stimulates the industry as well as the METS industries, the METS companies. So in conclusion, we know, and we've heard it many times before, the demand for copper, the demand for all minerals is definitely out there. It's undercover, and we're facilitating that sort of discovery for the range and the demand for minerals. The innovation is cooperative. It has to be cooperative between the many companies involved here, both actually Australian and overseas. It's commercializable, and we're now underway with our first 3-year phase of exploration. And in a substantial way, there's about 75 researchers currently underway, scattered across those 9 projects, as well as a total of 60 PhD students that are going to be engaged across it all. So I'm pleased to say we're underway.